For this video, we are going to discuss about the first part of linear permutations. Let us have this problem. A student wants to answer a 5-item matching type exam with 5 choices. How many possible answers can she have for this test? Let us answer. For this problem, note that the type of test that the student wants to answer is a matching type. Therefore, if the test has 5 items with 5 choices, this only means that if she answered a particular letter in a particular item, she cannot write the same letter in the other items. Example, if she write letter A in number 1, she cannot write letter A in number 2, 3, 4, or 5. Therefore, for this problem, this can be answered using linear permutations with distinct elements or permutations. How does this linear permutations with distinct elements or distinct permutation works? The number of distinct permutations of n objects taken r at a time is given by the formula n taken r, which is equal to n factorial all over the quantity of n minus r factorial. We also have to take note that if we are trying to get the number of distinct permutations taken all at a time, or arrange all the things that we have all together, then that would be n taken n at a time, or it's also equal to n factorial. Now that we have the formula for linear permutations with distinct elements or distinct permutations, let us now use this formula in answering our previous problem. So, let us recall the given or the problem. We know that we have a 5-item matching type with 5 choices. So, in this case, imagine having a 5-item test with 5 choices. So, the question here is that what would be the value of our n and what would be the value of our r so that we could apply the formula for distinct permutations. So, in this case, we have to imagine that all of these choices will be put in these 5 places. So therefore, these choices here will serve as our n, and the number of items will be the value of r in our permutation. So using the formula n taken r, this case, this would be 5, permutation 5, and we have to take note that the value of n and the value of r are the same. So therefore, this is just the same as 5 factorial. So, the answer would be 5 times 4 times 3 times 2 times 1, which is equal to 120 ways. So meaning there are 120 possible answers that a student can have. Now, let us try to change the question. What if it is still a matching type, 5-item matching type question, but it has a 6 choices? So what will happen is that the value of the 5 items will still be the value of our r, and the number of choices will be the value of n. Why is that so? Because it means that we still have to choose for 5 choices to put in this particular uh, number of positions or number of items. So therefore, you have to take 5 out of 6 choices. You have to arrange 5 out of 6 choices. So therefore, the 5 there will be the value of our R. And 6 will be the value of our N. So, ang pinakapalatandaan lang nito is that N must always be greater than R. Okay? So, therefore, N taken R at a time. So that would be substituting the value for N and the value for R. So that's 6 taken 5 at a time. Or that would be 6 factorial over 6 minus 5 factorial. So that would be equal to 6 times 5 times 4 times 3 times 2 times 1. Which is, we know that 6 minus 5 is 1 and 1 factorial is equal to 1 also. So, cancel. So this would be equal to 720 ways. How about if it has 7 choices? So if it has 7 choices, n becomes 7, r is still equal to 5. So that's 7 taken 5, which is equal to 7 factorial all over 7 minus 5 factorial. So that would be 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial. So cancel. So that would be equal to 2,520 ways. This time, let us have other examples. A shelf can hold 7 trophies. How many ways can trophies be arranged if there are 10 trophies available? So in this case, out of 10 trophies given or out of 10 trophies that we have, we are only going to arrange 7 out of it. So therefore, for the formula, we will just simply use 10 taken 7 at a time. So that would be 10 factorial all over 10 minus 7 factorial, which is 10 factorial all over 3 factorial. You can just simply use your calculator to evaluate this or simply expand. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial. Then, use your calculator to evaluate the following. So that 10 times 9 times 8 times 7 times 6 times 5 times 4 is simply equal to 604,800 ways. That is the answer. Okay, next example. 7 bands have volunteered to perform at a benefit concert, but there is only enough time for 4 of the bands to play. How many lineups are possible? So, in this case, 7 or 4 out of 7 bands that we have can only be arranged in a particular lineup for a specific concert. So, for us to know the possible arrangements of those 4 bands out of 7 bands that we have, that would be 7 taken 4 at a time, which is equal to 7 factorial all over 7 minus 4 factorial. Or that would be 7 factorial all over 3 factorial, or that's 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial. Canceling 3 factorial, we will have 840. So there are 840 ways to arrange 4 bands out of 7 bands that we have for a concert or for the lineups of the concert. And last example, we will have a company advertises two job openings, one for copywriter and one for artist. If 10 people who are qualified for either position apply, in how many ways can the opening be filled? So in this case, one for a copywriter and one for artist. So therefore, the position matters. So if there are two persons hired out of 10 people, okay, if one is a copywriter and one for the artist, and if they will switch roles, it will be another permutation. So it means, or it will be another arrangement. So therefore, it is a permutation problem. So therefore, we are going to use the distinct permutations because 10 people, meaning we have distinct elements to consider. So therefore, that would be 10 permutation, or 10 taken 2 at a time. So that would be 10 factorial all over 10 minus 2 factorial. So that is 10 factorial all over 8 factorial. So that's 10 times 9 times 8 factorial all over 8 factorial. Cancel. So we will have 90 ways. Alright. So there are 90 ways to have this particular opening be filled out of 10 people who are qualified in those positions. So that's it for our linear permutations part 1.